we're going to find out that this is true whether you use a cone or any pyramid with the same base. That if you have your volume, and the volume of any prism is whatever the area of the base is times by the height. And a good visual of this is your textbook. Technically, your textbook is pretty close to a rectangular prism. I mean, some parts of it are a little bit wider, but if we imagine this a perfect rectangular prism, your textbook is a great example of a rectangular prism. It has a cover, and your cover has an area. Then you open it up, and it has page 1. And page 1 basically has the same area as your cover. Page 2 has the same area, page 3. And basically you have all 548 pages stacked together make your textbook. Volume is about taking up space. Your textbook takes up this much space. To figure out the volume formula, it's basically saying, take one of the pages of your textbook and stack them up until you get the height. And so the area of one page multiplied by the height adds up all of those areas, and that tells us how much space your textbook takes up. So the formula for any prism is whatever the area of the base is times by its height. Now, a regular prism, and we'll draw one right here, regular rectangular prism, and then we have the same rectangle up here, so I draw straight up, straight up, straight up. And first of all, I'm going to do this. It's on your formula sheet. It has, and you might remember this from grade 9 and grade 8, that the volume is length times width times height. Is that on your formula sheet? Well, they have the area of the base. Okay. Might have been on your formula sheet in grade 9. Now I'm going to take this formula and just add brackets around that length times width. Because if this is my length, and this is my width, and this is my height, do you see that what I put in the brackets is just the area of the base? And sometimes on your formula sheet, it writes it like that we're just figuring out the area of the bottom and then multiplying by the height to be able to figure out the entire volume. And then when you go to your pyramid or to a cone, it always works out perfectly to be 1/3. And I could take any shape if I had a pyramid and pour water from one into the other, and it would work out perfectly, always to be 1/3. Now, if you love mathematics, I would say, hey, part of your brain should be going like, well, why does that work? We don't have time to explore it completely, and you're not required to, in this class, explain why it works. But if that intrigues you, check it out on the internet. Have someone explain the why, see if it makes sense to you. Calculate the volume of the right square pyramid. So with volume questions, we are going to use formulas often. Whereas surface area, sometimes you had to open it up and make the net and find out a whole bunch of things separately. Volume formulas we can find directly. So we have a pyramid, so it's going to be 1/3, and I'll go to your formula sheet and use exactly and write out exactly how it's written. And I'm going to put a note with the H that this is actual height got to be careful here because we have two different heights that we're using in a lot of our questions. Sometimes we have slant heights, sometimes we need actual heights. That's going to be one place where it's easy to make lots of mistakes. So we have to see in this question, you're going to be very tempted just to write, oh, there's 7, looks like the height, just plug it in. But is that 7 the actual height, or is that 7 the slant height? You have to look at the diagram carefully. Here, that 7 is the slant height, okay? So we need to find I'm going to write height in green because the height is from the top right to the center, that green dotted line. And in order, whenever you have slant height and need to find height, or you have height and need to find slant height, we're always going to, and this is a little bit hard to visualize, think of a triangle. And I'll draw the whole triangle in purple. The triangle includes using the slant height and the actual height. And this would be a 90-degree angle in there. I'm going to take that purple triangle. Oh, is this bothering anybody else? Oh, and it's going that there was no T on the end. Here we go. There we go. So we're going to redraw that triangle. So your spatial ability here, we take a 3-dimensional shape, and I'm going to want to put it in 2 dimensions onto my paper. Hello, how are you?
Oh, well, better now that I see you.
I'll just pause it.
I'm just going to draw.
So we have to label some things in here. We were told that the slant height was 7. We want to find this actual height in green. And from this triangle, can you see that the bottom of this is halfway across the whole thing? We're told that the base is a square, so that makes this part right here half of 2. It'll be 1. And now we can do a squared plus b squared equals c squared. But hypotenuse is always the longest side. It's always in a squared plus b squared equals c squared, the number by itself. So in this case, what we're trying to find is one of, on a triangle, those are called legs. We're trying to find one of the legs. So this would be 1. 7 squared is 49. And we use our skills from grade 9 to solve for this. So we want to get the h squared by itself. We'll move the 1 over. And one of the things that, you'll pass the calculator. One of the things that comes up on quizzes and tests is how we have to be careful with rounding. So if I go to my calculator and I do the square root of 48, I get 6.928. I'm going to change this. But I've rounded that. So there's ways that we can use our calculator, and maybe I'll bring up the calculator on the screen as well, so that we keep things exact. So while that's loading up, we now have the height, and we can find our volume by just plugging things into the formula. The first thing we need to plug in is area of the base. What shape is the base? It's a square. How do you find the area of a square? Length times width. So I'm going to just write 2 times 2 in there. That's my area of a base. Times by my height. And for me personally, I would probably keep that square root, because then it's exact. If we don't use exact numbers, we might round wrong in the end. Okay? So we're going to go to our calculator. I'm going to show you a couple of things. So first of all, if you had done square root, and on the graphing calculator square root button, you have to push the second button. If I do square root of 48, I get 6.928. If I was using my calculator to do calculations, I'll show you a couple things you could do. You could do 1/3, 1 divided by 3, and, okay, for me personally, if you have the newest version of the graphing calculator, you can hit alpha y equals, and a menu comes up. So if you have the graphing calculator and you want to check if this works for you, it's really cool. Alpha button, and then the y equals, this menu comes up. If you push enter on the first one, you can actually write your fraction of 1/3 as the fraction 1/3. Really nice. Okay? Times by, sometimes you can do a little bit of mental math, times by 4. 2 times 2 is 4. Times by, now personally I would do square root of 48. This is the exact answer, 9.2376. So if the question, and I should reread, first thing, whenever you get in the final answer, so I'm going to write 9.2376. Okay, I've got my answer, it's rounded. I will not be taking off marks if you, when you round, if you don't remember the approximation sign, but I'll put it in there. I'm going to reread the question, see, does it have units? Yes, it has feet. Did it tell me what to round to? No. So I would be okay, and volume units are always cubed. It's good to reread the question to check for rounding and to check your units. Okay? If this question said round to 3 decimal places, you'd have 9.238 feet cubed. Again, once you have a final answer, it's good to make sure you've got your units. Good to put a square box around it because you've done a lot of figuring in these questions, so you can sort of say, here I found my final answer. AP Calculus likes you to put a box around the final answer. Crazy thing is, next year some of you are going to be taking grade 12 math. It seems like I just started grade 10, and now my teacher's talking about next year I'm doing grade 12 stuff. In grade 12, if they don't tell you what to round to, they want 3 decimal places. If I don't tell you what to round to, you have a choice of rounding. Okay? But I'm going to show you dangers of what would happen if we did the same thing, but instead of the exact value, we just said, oh, it's 6.9. I'm going to just, square root of 48 is 6.9, so I just type in 6.9. I get 9.2, and I write that as my final answer, but the question says round to 3 decimal places, and you're like, oh, well, I only have 2, so I'll just leave it as 9.2. Notice that you wouldn't have those 2 numbers. So if you round early, it could cause you a problem. Sometimes that problem goes away. So for example, if I had used 928, I'm still rounding early, I would get 9.237. How does that match up? I would still lose a half a mark for rounding because it's supposed to be 9.238. So if the question said round to 3 decimal places, and you rounded early to 3 decimal places, and then kept working, you might have a chance that your final answer is slightly off. So the general rule is when we're working with math, we don't want to round until the end. So that's why I really like using the square root of 48. Okay? Some other things, some other tricks with this calculator. If you have this one, I'm going to show you. So I do 1/3 times 4, and then I don't want to write the square root of 48, but I could go, and when I figured the square root of 48, I could highlight that number and push enter, and then it would type it in. And not only does it type it in up to 3, it also types in, although you don't see it, probably another 8 numbers. And then when you push enter, your number, look how it matches up perfectly with the exact answer. Okay? But I would encourage you to use exact numbers right until the end. So in volume questions, sometimes we still have to do a squared plus b squared equals c squared. Careful between the height and the slant height. It's a favorite thing to ask in this unit. Why? Because it's the #1 thing that people make mistakes with. So it's going to ask you it lots. But if you know about that and are prepared for that, then hopefully you're not going to be able, that's not going to catch you. Right, here's the same idea. If the area of the base, which I'll put in green brackets here, is length times width, this is exactly the same formula because you have 1/3 area of the base times the height. Determine the volume of a rectangular pyramid with base dimensions 3.6 by 4.7 and height of 6.9. So I go to my formula sheet. It's a pyramid. And I have that formula. The base is a rectangle. If you want to get good at drawing pictures, it's not bad. When we draw a rectangle in 3 dimensions, draw one side, draw the other at an angle, so it's sort of like a piece of paper lying on the table. Pick a point above, label everything that you know. This is 4.7 and 3.6. And the height, which goes right from the center all the way to the top, is 6.9. How nice is this? We don't have to find the slant height. Our formula uses the actual height, and the question gave us the actual height. So now you can type in 1/3 area of the base. Well, that's length times width, so that will be our 4.7 times 3.6. And then our height is 6.9. Now, if you have a scientific calculator or a graphing calculator, it is really important that we type in all of these things all at once. So the fraction of 1/3, you could just do by doing 1 divided by 3, times by, if you want to put it in brackets, 4.7 times 3.6, close those brackets, times by, and then our height was 6.9. What we want to do for calculations is if we can put everything in all at once, that's great. Because then we can get an answer directly from that, 38.916. I've got my answer. I need to check, did I have units? I need to check, does this question want me to round? So I reread the question, answer to the nearest 10th. So that'll be 30.8.9. We're using meters. And there we have our final answer. So again, I think the volume questions, because you usually can just plug it in and add it up. Surface area, you have to do a lot of different things separately and then add up all those separate things at the end. The volume formulas are a little bit easier. And I showed you the idea of the cone at the beginning, that you could pour it into a cylinder and get also 1/3. Notice the volume of a cylinder in the green brackets. What formula is that? Do you recognize the formula that's inside these green brackets? What does pi r squared represent? That's the area of your circle, right? And same idea as the textbook. If you cut out pieces of paper that were circles and stack them up, the shape that you would get would be a cylinder. So all we're doing is taking the area of the bottom, stacking it up, multiplying by the height, and that gives you the volume, how much space that shape takes up. So again, we go to our formula sheet. And then make sure it doesn't say area. Oh, okay. Something on your formula sheet for the cone. This is what it looks like on your formula sheet. Sometimes this causes students issues because they're like, do I have to use everything? No. They're just giving you the formula in both forms. They're giving you the formula saying you could use just the area of the base times the height, but they're also telling you, oh, it's obvious that the area of the base is a circle, so we could just use the circle formula right in there. So you're not looking somewhere else first. Okay? So you could use either this, which is in the purple box, or this, which is in the orange box. You get to choose. I personally would probably choose the orange box because it has everything you want to fill in all at once. I would look at my orange box, and first thing I would do before I go further is decide, do I have everything that I need? Okay, I'm going to need my radius. Does the question tell me my radius? Not directly, kind of does. What does it tell me? Diameter. So first of all, I might take a little bit of time and write out I have to figure out what my radius is. Half of the diameter. Secondly, does it give me the height or did it give me the slant height? It gave me the actual height. So much nicer when it gives you the right numbers. Okay? So now we can go right to our formula. And we can plug in everything that we see. We've got pi. We've got a radius, which is 4. And that's getting squared. And we've got a height, which is 13. And we just plug those numbers in. Generally, when we insert things into a formula, we kind of put brackets around that number to say that number got inserted for 13 for the H, 4 for the R. And you can type this into your calculator exactly like this. 1 divided by 3. You need to find the pi button on your calculator because if you use 3.14, you will be rounding early. So you want to make sure we're using the actual exact value of pi. And then I could put brackets here and square that. Or I could just do the mental math and do 16. And I could put brackets here and put the 13. So if you type it in exactly as your calculator, as you wrote it, your calculator should figure that out. Some of you might have older scientific calculators that doesn't necessarily work that way. So now 217.817. I guess I rounded. What are my units? What does it want me to round to? Millimeters are my units to the nearest cubic millimeter. Let's highlight that. Nearest cubic millimeter, how many decimal places is that? 0, right? Because you're rounding to the nearest whole number is basically what that's saying, okay? So sometimes we get used to words like nearest tenth, nearest hundredth, or round to 2 decimal places, but I wanted to highlight this one because sometimes when it's just wanting you to round to the nearest whole number, it might be written this way, and then that can be a little bit tricky. So here's my final answer, 218, include my units. It's a volume, so my units are cubed. Millimeters cubed. Can you visualize a millimeter? It's pretty small. Can you visualize a millimeter cubed? That would be a little cube where all the sides are 1 millimeter. And then you have 217 of those that you dropped on the floor and have to pick them all up. Oh, they'd be like little tiny pieces of sand almost. That's how small they would be. This isn't a very big cone. If they gave me that cone for an ice cream, I'd be very disappointed. Generally finding volume, very easy. If I wanted to make a question a little bit more complicated, I could tell you the volume, and then you have to use the formula to work back to find something else. Again, I'm going to draw a picture. It says a cone has a height of 8 meters and a volume of 300 meters cubed. So there's a circle on the bottom. Draw a cone. It told me the actual height is 8 meters, and it told me the volume was 300 meters cubed. And the question is asking us to find the radius. So we do have a formula. I'm going to write out the formula for the volume, 1/3 pi r squared times height. There's our formula. And the question is asking us to find the radius of the base of the cone. So it wants us to find that part right there, the radius. If you have a formula, like we have a volume formula here, this volume formula has 3 variables: volume, radius, and height. If we want to find one of those variables, we need the other ones to be there. So for example, when we wanted to find the volume, we needed to plug something in for radius and something in for height. Now, we want to find the radius. Do you have something for volume? Yes, 300. Did the question tell us the height, or did it tell us the slant height? Okay. I'm going to get you to check every single time, but it told us the actual height. Great. Don't have to do extra work finding the height. So I can plug into this formula everything that I know. I know the volume is 300. I don't know the radius, so I'm going to leave that as an R. And I know that the height is 8. Plug in everything that I know, and now I need to solve for R. And right now that R, I'm going to put a box around it, is connected to the squared. So I need to get the R by itself. So first of all, I'm going to get the R squared by itself. Okay? Oh. You can take your time, or you can do it fast. I'm going to start by taking my time. Then I'm going to show you an easy mistake that you can make whether you're taking your time or doing it fast that sometimes causes a problem with the calculator. Okay? If I wanted to get the R squared by itself, I need to get rid of these other numbers on that side. So if I was taking my time, maybe I choose to get rid of the 1/3 first. What's the opposite of dividing by 3? Multiplying by 3. So if I multiply this side by 3, I have to multiply this side by 3. And this multiplying by 3, I did that because it's the opposite of dividing by 3. That would cancel that out on the right-hand side, and I now have 900 is equal to pi, and I still have the R squared, and I still have the 8. My goal is still to get the R squared by itself. So the next thing I am doing on that side is I'm multiplying by 8 and pi. So I'm going to do a little bit of a shortcut here, and partially because I want us to make a mistake. Okay? So the little shortcut is the opposite of multiplying by 8 and pi would be dividing by 8 and pi. So I'm going to do, color code things the way I want to. I'm going to divide by 8 pi here, and I'm going to divide by 8 pi here. Mathematically, dividing by 8 will simplify and cancel that out. Dividing by pi will simplify and cancel this out. And now, let's make the mistake. So, obviously you can't do this mental math. We need to do our calculator. I need to get an answer. And some of you will get one answer, and some of you will get another answer. So I want to have a show of hands. Who got which answer? Okay. If you did it right, or you made the most common mistake, you either got 353-ish or 35-ish. Okay? If you got something other than 353 or 35, then you made another catastrophic mistake that you don't know how to use your calculator, and we'll fix that. But you can come see us and say, I didn't even get any of those answers. Okay, show of hands, how many people got either the most common mistake or the right answer, either something 353 or 35? And how many people didn't have a calculator? Didn't try it? Okay. Bring your calculator. All right? Because you want to find out if you're making the mistake or not, because whatever you do first right now is most likely what you would do first on your quiz, even if I showed you the right way. I'm going to show you the right way, but for those of you that are making the mistake, you would have probably made the mistake the same. If I just showed you the right way to do it, you'd be like, oh yeah, makes sense, get your test, you're going to make the mistake. The mistake is this. Your calculators are smart, but sometimes they can't read your mind. So most people make the following mistake. I can't remember what the numbers are. 900 divided by 8 pi. 900, hit the divide button, hit 8, hit pi. Right? My grade 12 still make this mistake. This is the mistake. And it's not easy to see the mistake because it looks like I typed in everything as it should be. But your calculator does order of operations. And what it does here is it does 900 divided by 8 And the next thing it says, oh, you want to multiply by pi? It multiplies by pi, which makes that pi on the top, not on the bottom.
Okay, wait, so is 35 also wrong?
35 is going to be the right one.
Wait, I got that though, and I did that exact same thing.
Now, it depends on which calculator you're using. So let's see how yours turned up when you wrote it in there.
What was the numbers again?
900 divided by 8 pi. Ooh, that's interesting. Okay. I would tend to say there's something that your calculator, maybe because you use yours has the divide sign instead of the slash sign. I'm not sure. Okay. But if we do 900 divided by and put the 8 pi in brackets, we get the 35, which is the right answer. It's kind of nice that your calculator could read your mind. But had you wanted it to multiply afterwards, then it would then give you an error. Okay? If you have the graphing calculator and you have the fraction button, you will never make this mistake because the fraction, you can write it exactly as you see it and it comes out perfectly to 35. So that fraction button, I'm going to tell you, is really nice. Some scientific calculators let you write in fractions as well. Perfect. That'll make you make less mistakes. But if you do type this into your calculator, I'm not sure if you're going to can make a note of this, that 900 divided by 8 pi on your calculator would be 900 divided by bracket 8 pi to avoid that mistake. Okay, my grade 12 still make that mistake tons, so we'll see it now already. And we get our answer, which is that r squared is equal to, we finally got the r squared by itself. Go to my calculator, 35.809. And sometimes what I do in my math to tell the teacher that I remembered not to round early, but I don't want to write too many numbers, I just put 3 dots there to say, I'm keeping all of my decimal places, Mr. JR. I'm not rounding early. So now I need to square root that number to get r. So I go back to my calculator and second square root. And a lot of calculators can let you pick the answer from before. The graphing calculator, you can either highlight it or right above the negative sign it says answer, so I can go hit my answer button and it says, okay, we'll take the answer that you got and we'll square root that. Push enter, 5.984. Read the question to the nearest, highlight that. And maybe you have your highlighter with you as you're doing questions on quizzes and tests, and wherever there's rounding, you highlight it to remind yourself to look back at it later. Okay? To the nearest meter, do we have units? Units are in meters, so to the nearest meter, and then I've rounded right at the end. Okay. Last class, oh, this is perfect. Last class, you got this paper to figure out surface areas, which are harder, and then I got you to split it in half because it has volumes as well. Okay, I gave you the answers last class for the surface areas of the first 3. Work on the volumes as well. If you finish those, notice on the next page we do have homework on page 42. And we're going to take some time. It's really nice. Miss Ross is here, so she'll be able to help by walking up and down the rows as well. If you have any questions, or if you had any questions from previous homework, and it doesn't work for you to come to Math Help, you can ask us at this time as well.